Hello! In my previous video on my Ben Eaters inspired EEPROM programmer, you've seen me testing the breadboard without the Arduino. In the present video I will show you a test with the Arduino and a special program with extensions to Ben Eaters program. In order to recap, the Arduino has not enough digital pins to service all the pins of the EEPROM. Therefore, Ben Eater used two shift registers, which give you an extra 16 bits, and the data for that are shifted in serial to the shift registers. The shift registers are used for setting the address data, and the data for that are shifted in on one pin of the Arduino and resulting in total 16 bits, of which only 11 are used for the actual address. The red LEDs display that data. 4 bits are unused, but bit 15 is used to set the output enable pin of the EEPROM. We have now applied power to the board, but we hold the Arduino in an early setup state where there is no output conflict between the Arduino and the EEPROM. On one hand, the Arduino pins for getting and putting data to the EEPROM are set in the input mode, so it will not output voltages to the EEPROM. On the other hand, bit 15 of the shift registers is high, which prevents the EEPROM to put data on the data lines to the Arduino. In other words, it is in the input state 2. Therefore, there is no conflict between Arduino and EEPROM. We now release the reset button of the Arduino, and the first thing the Arduino will do is erasing the whole EEPROM. We see the address data being incremented, and we see that bit 15 is high, which allows the Arduino to write data to the EEPROM. The program writes random, so meaningless data to the EEPROM. An extra feature of this program is that without rewriting the program, we can prevent the Arduino from erasing the whole EEPROM by setting the A2 analog input of the Arduino to 0. And we can prevent the Arduino writing to the EEPROM at all by setting A1 to 0. And a very special feature of this program is that we can slow down the whole process by setting A3 of the Arduino to 1. We see shifting in the data one by one. First the write bits, the bit 15, followed by 3 unused bits, and when this all is in place, a random number is written to the EEPROM at address 0. Now there again comes the write bit, followed by 3 unused bits. When they are in place, another random number is written at address 1. Now for address 2, first bit 15, 3 unused bits, another random number at address 2. We follow this, bit 15, 3 bits, and this will be written to address 3. Notice that the bits are mirrored left to right, so in fact we must turn the situation, and we now go for address 6, I suspect. Yeah, address 6 is written. Now what if we are preventing the Arduino from erasing the whole EEPROM by setting A2 low? Then the next step for reading back the data is carried out immediately on restarting. Three bits are shifted in, which are the 3 unused bits, and bit 15 stays low, which means that the EEPROM is ready for reading it. And so the Arduino does. That was address 0, now follows address 1, 3 unused bits, bit 15 stays low, and address 1 is chosen. And the data read into a variable and printed out on the serial monitor of the Arduino, which we will see later on. Let us finish this demonstration by switching back to high-speed mode. After one cycle, this will happen. And now the Arduino is reading the rest of the data.
In the header of the program, the extra features with respect to the Ben-Eater version are given here. In the setup code, which starts here, one of the first things done is reading the 3 analog input pins. And if read-only and inhibit arrays are both false, then one of the first things done, and we have seen that, is erasing the EEPROM. In this routine, the bit 15 LED was on. If that is done, the contents of the EEPROM are read, and in that situation, bit 15 LED was off. Now let me show you how the slow motion feature is implemented. For that we scroll to the beginning of the program, and here we see the set address function. There what is done is checked if slow motion is chosen. And by the way, first it is checked whether we have to read or write the EEPROM. If we have to read, bit 15 is cleared. If you have to write, bit 15 is set. But now for slow motion. Here, if slow motion is chosen, the control is rerouted to another function, namely set address slow, which is here. Now, among other things, bit by bit, data is shifted in the shift registers. And there are, of course, the necessary delays here and there, and you can set the time of that. So this is the way how slow motion is implemented. The other things are rather pretty much the same as Beniter has done. We have here read EEPROM, the function read EEPROM, here the function write EEPROM, and so on. Finally, I want to show you that after erasing EEPROM and print contents, which we have seen, the program comes in a loop as usual, here the void loop, and what this loop does here, it gives a few examples how to use the functions. The loop address is incremented each time the loop is looped here, and the first thing is done, it prints the address from that cycle. Then it sets the address for read, but do not actually read to a variable. The address setting for read is done by making this boolean true, which stands for output enable, which is here an active high boolean. So if it's true, the output of the EEPROM is enabled and can be read, which is not done here, but it is done here to a variable, and the variable is byte. Then pretty much the same is done for write, set address for write by choosing this false, but don't write because it's not picked up, and here by using write EEPROM, it's actually written, and what is written is the address itself, loop address. And finally, the EEPROM is read back by reading the loop address and putting it in byte, and then increment it. I will show you that in on the breadboard to end with.
Now the program is in the void loop at address 0. Now at address 1, reading, writing. Address 2, reading, writing. Address 3, reading, writing, etc.
The loop in the serial monitor and in slow motion looks like this. First, the address is set for read, but not read to a variable. Here you see the address, and bit 15 is 0, which means read. And by the way, this is the address 5. This whole thing. These are the 3 unused bits. Now, address is assigned to a value, and the value is the address itself. Now we do the same for write, but we do not write yet. Now bit 15 is 1. These are the 3 unused bits, and it's not written. And now we are going to write to a value at the same address. Address 5. And this is the value 5 is written to that address. And so on. Finally, the address is read back. And not surprisingly, this is the value 5. And so on for the next loop at address 6. Now, you can download the code from the description below the video, and I thank you for watching.